Hello everyone, I hope you are all doing well. My name is Amin Abdullah and I'm a creative developer based in India. As many of you guys have been requesting to me on LinkedIn on how to make a shader effect and how to make this and that and how to make this magical beautiful effect using shaders. And I'm finally here making a beautiful effect for you guys using FBM noise and vanilla JavaScript. So yeah, let's get started. Now before we get started, I just want to quickly show you what we are going to make today. Now look at that. That's the beauty of shaders. And everything is randomized so that you're not gonna see the same thing every time. Now that's beautiful. So let's get started. So I have set up a boilerplate for you guys that you can clone it from my GitHub repository, and all the links are in the description. So go check it out, clone it, and come back to the video. So before we get started with the fragment shader, there are some things you need to notice in the boilerplate that I have set up. And if you check it, you can see a complicated formula here that requires like a tan formula, and yeah, it is very confusing, including pi. I don't know these two big values, 180. Okay, whatever that is, I'm going to tell you what it is used for and why we use it. Okay, so before getting to that, I want to tell you a problem that we face in production level. So we want to mix the WebGL and HTML images in order to use this. So I have a plane here, right? And I have an HTML image that I have aligned using CSS, and I want this WebGL image to go in the same position as my HTML image. So how do we do that? So we use the get bounding client rect to get the top value, the left value, then the width and the height, and we use that to position this WebGL image, the WebGL plane basically. So but before that, one thing you have to notice is we use units in WebGL, like 1 unit, 2 unit, 3 units, but in HTML we use pixels, right? Everything in the web is in pixels. But if we can't get this 3.js units into pixels, we will face a lot of issues while making it responsive. So normally 1 unit in 3.js is equal to a few hundred pixels. Let's assume it's a few hundred pixels. Alright, I don't know the exact value, but let's assume it's 100 pixels. What we want is, we want this 1 unit of 3.js which should equal to 1 pixel. So what do I mean by that? So if I'm taking 100 units in 3.js, what should be it equal to? What should be the value of 100 units? So it should be equal to 100 pixels in HTML. So in order to achieve this mixing of WebGL and HTML dimensions, we use this technique that I've learned from Yuri Atoik, and it is a very useful technique, and I'll tell you what is happening here. So we need basically two things that changes everything in this formula, which is this height, the 600. Make sure this height is equal to window dot inner height, and the 600 which is equal to this camera dot position in the z direction. So make sure these two values are 600. All right, and then let's say you have done everything I said and you have set this frustum to 100. Okay, now you can't see anything. Why? Because you are clipping the frustum while your camera is in a very far position. So make sure to give this a big value, around like 2000 or 1000. Okay, that part is done. And if you want a detailed explanation, like show it in practical, show it in a production level, why we use it, and I've made another video about merging WebGL and HTML, so go check it out. Okay, now that's done about the mixing of WebGL and HTML. So the next part is the uniforms. We have some basic uniforms here, like the time, the U texture, and the U displacement, and I'll tell you what it is. We have this mouse over position that we set up using Raycaster, and this resolution, which is basically the window dot inner width and window dot inner height. Then comes this image that we're going to use in this plane, Then comes this displacement map basically. So if you check the public folder, you have this eyes, normal one and normal 3, and these three kind of look similar because of that purple color. So I'll tell you why we use it. We use this as a distortion for this image we're gonna use, and it's gonna look cooler, it's gonna look much better. Then comes the image size. Okay, so this is also one of the most important concepts when you're merging WebGL and HTML. So when you're setting up the image in this plane, the image can look a bit stretched. Alright, so if we get that in CSS, what we do is we set up the background size cover property, right? But we don't have that in GLSL, so it's gonna look stretched. So in order to get that background size cover effect, we have this function that will help us achieve the same effect. So in order for this to work, we need three variables, which is the UVs, which will get this from a vertex shader, and this texture size or the image size, and the quad size. We can take the quad size as the resolution of the window and image size as the natural width and natural height of the image of the texture. So how do we get this width and height from this texture? So when we are loading the texture, we run a function. Alright. Now inside that function, we have the texture width and texture height, and we can access it by saying images, the textures, dot image and dot width, and similarly we'll get the height, and then we'll pass these two as a uniform to the image size that we have set up here. And that's it, and that's pretty much it about the boilerplate. And there's also one more thing, that is the Raycaster. That is very basic. We set up the basic mouse move, then we check if something is intersecting. If a mesh is intersecting, then we'll get the UV values of that mesh, then we'll set the mouse over position to this UV value. Done. Okay, so now we can get started with the shader part. Okay, finally now we're getting to the shader part. So if you check it, we have a very basic boilerplate here with a red color plane. Alright, and then I have imported all of the uniforms, and I've set up the varying UVs here. And then one thing you have to notice is, as I've said before, we get this VUV cover effect using this function. Okay, so basically what we have to do is, after setting these uniforms, you come and import it here. Then we set the VUV, we set the varying VUV, and we call this function. Then we pass the UVs. Alright, then we pass the image size and resolution. Done. Very easy. Now we can focus on the fragment shader part. Alright, so let's get started by outputting the image. Alright, so let's say for image is equal to texture 2D, texture PUV, Copilot doing its job, and let's just output it. Okay, now we have this image, and I'll show you what this VUV cover does. What is it? I'll show you what this VUV cover does. I'm going full screen for this. Okay. When I refresh, okay, now the clipping is different. Alright, now as I resize the screen, now this gets clipped automatically. The image gets clipped automatically. But if I'm not using this, and let's say I'm using VUV is equal to UV. Let's say I'm using that. Okay, now you can see the image is stretched, and if I'm going full screen, look, it looks okay at some point, but when in shorter screen, it doesn't look great at all. It looks stretched like this. So we don't want this. That's why we use this cover function. All right. Okay. So the next part is, as you have seen in the video, thumbnail, we need a circle that follows our mouse around. All right. So how do we create a circle in GLSL? So there's a function called a smooth step that we use to interpolate between two values, and I'll show you that smooth step GLSL function. Okay, we need a book of shaders. Alright, Now, if you go to the book of shaders, it's a very good resource to learn shaders. Okay, so you come in and you see this Hermite interpolation. That's what we call it mathematically, the Hermite interpolation between two values. So here we go, a smoother function. Then we have two edges and the value. This value determines the transition of these two values. Alright, this edge 0 is the lower edge 1 is the upper edge, and x is the source value for interpolation. We can interpolate we can have this transition between these two values using this flow tags, and I'll show you how it works. So we have the smooth step function, we have 0.1 and 0.9. Alright, so what is this st.x? We don't have this in our boilerplate, right? So I'll tell you what this is. Basically the UVs. So if I change this UV in x direction to the y direction, now we get this gradient in the y direction. Unless I'm changing these values. Whoa. I think we are starting to understand what this smooth step function does. Wow, that is cool. Now that is the smooth step function. It creates a gradient, I mean say a good interpolation between two values. So that's what we're gonna do, but we're gonna create a circle with it. Alright, so let's say float circle, and one thing to notice is we are using a float value, and we can use a vector 2, vector 3, vector 4, but in our case we only need a float value. Alright, let's say smooth step, and the first parameter we're gonna pass is the radius of the circle. Alright, radius of the circle, and the second one is how smooth this edge of the circles, like the edges of the circle, right? How smooth it's gonna be. Let's leave it at 0. Alright, and the next thing we need is the coordinates, like the distance between the UVs and the mouse position. So what it does is it calculates the distance from the mouse coordinate to the VUVs. Alright, so we need that. So let's just leave it as mouse distance. Alright, and then we come here, we declare the radius, float radius, which is equal to, let's say, 0.1, and the last thing is to get the mouse distance. How do we do it? How do we do that? So the mouse distance is a vector 2 variable. We have a x and y direction, right? We need the x and y direction of the mouse, so it's a vector 2. What is it? Yes, vector 2 you mouse over position. So let's just save it to a temporary variable called as mouse. Alright, now what we need is we need the mouse distance. Okay, float mouse distance, and we all have studied the distance formula in our mathematics, right? So there is something similar, I mean the exact same thing in GLSL. What it does is, so we need to calculate the distance between the VUVs and the mouse. Alright, I mean it doesn't matter if you write mouse first or VUV first, it gets the same thing. And if you check here in the documentation, you get this, it returns the distance between 2 points, which is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. I think you all are familiar with this formula. I think they also mentioned the same formula using length. You also have a length function which does the same thing. So instead of separating these two with a comma, we say mouse minus VU. Okay, this also doesn't matter what comes first. If you write mouse first or VUV first, doesn't matter, it's the same thing. And if you check the documentation of length, come on, okay, now you see the formula, right? The x2 minus x1 the whole square, and they are taking the both x, like the x2 minus x1, right, as a single component. They already calculated it, so we get this formula, same thing as this distance, but I think we all can go with the distance because it's easier to understand. Alright, so we have this, so let's check what we have. Let's output what we have. Okay, I think we are getting uh okay, spelling mistake. Radius. Okay, now you should be able to see the image, right? Now let's output the circle. So we're just passing this to the red channel, then we move this here. Oh, let's go, we have the circle here. Isn't that cool? Now if you want the circle to a bit bigger, increase the radius. Wow, there you have it. There you have the circle. Now the first step is done. So what's next? Now we need to distort the edges of the circle, but how do we do that? So there are some noise algorithms we can use this to randomize the edges, like the, what is it, the distortion, which is gonna make it look much cooler. So the noise function we're gonna use here is known as a factorial Brownian motion. I think I spelled it right. So it's basically FBM noise. So if you search this FBM GLSL noise GitHub, you're gonna come to this GitHub repository. I'm not gonna spell this guy's name, I mean pronounce. Then when you, if you click on this 2D GLSL, okay, you get this function. Now come this, copy everything except the last line. Alright, now close this. Okay, it looks complicated, I know, but we don't have to understand this how this works, because let's be honest guys, we don't understand shit. I don't understand shit what's going on in this, but what we need to know is how to use it and not what how it works. All right, so if you look at the input, we need a vector2 value, right? So we need to pass a vector2 value. So let's create the noise. So float noise is equal to FBM. So in most of the noise algorithms, we pass the VUVs because we are playing with the fragment shader, right? So we need to play with the pixels. So VUVs are the core concept of fragment shader. So we're gonna play with this VUV for a while. So let's say we have this, and let's add it to one of the edges. Either we can add it with this edge 0 or edge 1. So if you want this kind of, what do you say, intelligence, then I think there's an extension for GLSL intelligence. um yeah, shader language support, and there's one, yeah, WebGL GLSL editor. So you make sure to install that if you want this kind of, what do you say, intelligence. And yeah, so either we can add this noise, we're gonna add this noise to this edge or to this edge, and let's see what happens. Wow, I think we're getting something weird here, but yeah, it looks cool. You get something like a blob. All right, so let's just multiply this VUV with a very huge value. Whoa! Now we're getting somewhere. Now we're getting somewhere. Now that's what we want. Isn't that similar to what we are gonna create today? Right. But the size is a bit too much. But even if you try decreasing the radius, it won't decrease much. Why? Because we are adding it here. If you don't, where is it, the noise? If you don't multiply this with the same size, it's not gonna decrease. So either you can multiply this noise with a very small value, or you can just multiply the radius with the noise. Okay, now you can see it got really small. So let's spike up the value. Okay, now we got that effect, right? Okay, now the last part left is to blend this noise and the image. So let's go back to the image. Okay, now we have that here. Now everything in Fragment Shader is based on the UVs. So if we want this noise to come on this image, what we have to do is add the noise. Just add the circle basically. Let's see what we get. Whoa, that is so cool. It's this simple to create something so beautiful. Just look at that, so beautiful. I could play around it with it for the whole day, man. Just look at that. But if you notice, the colors are a bit dark and it's not blending in properly. So what you can do is you can multiply it with a very small value like 0.1. Whoa, now you can see the blending. Now you can see the noise blending with the image. And let's keep it 0.2 or 0.3. Okay, now you can see that. It's so freaking cool, isn't it? But instead of giving it like this, let's just create a temporary VUV variable. So let's just copy this and let's say write to displays UV, which is equal to our value, right? And now instead of just writing all the formula here, we can give it like this. So it gets the same result. And now here comes the part where the displacement, the normal maps play in. Now if you check the JavaScript file, I have set up all the normals in an array so that I can switch between them very easily. And maybe if you want to set the wrapping, you can, but it's not necessary. But yeah, so we set the udis texture to the normals, then we come here. Let me set this to the 0 first. Alright, so let's come here. Now, how do we add this normal map to our displaced UV? So let's just get the, what do you say, the texture of this noise displacement map. So let's say vec4 u displacement placement, I mean display this, let's keep it as this, which is texture 2D of u disp. Exactly, Copilot knows its job. This is the uniform, and then we have this texture. Okay, so when we're playing with normal maps, we only take the R value. You can either take the R or G or B. Alright, I'm taking the R here, it doesn't matter, it's the same thing. And when you type the R, it will throw an error, dimension mismatch. When we're putting dot R, we are only taking one value from this vector 4. So if you put like RGBA, okay, now it works. But we don't need the GBA value, the green, blue, and alpha channel. We only need the red channel. So we are accessing only one value from this vector 4. So just give it a float and everything works, because it's only a float value. The red channel is only a float value. Okay, so now comes the last part where we add this displacement or normal map to this displaced UV or to the circle, right? Now, instead of doing it like this, we can also say displaced UV plus equal to what circle, which is multiplied by 0.3. Let's say what we have. We have the same effect, same result. I'm just showing you guys that you can also do it in this way. So it is a bit more cleaner. We can get a bit more cleaner code this way. Okay, so what is next? Now I'm just setting the normal to 0 first, alright? And then we'll check out this ice displacement map or normal map. So how? I want this normal map to distort only the area inside the circle. So what I'm gonna do is I'm gonna say circle, then I'm gonna say multiplied equal to displacement. Okay, if you guys look closely, you can see a grainy effect, a bit grainy. Okay, let me just increase the intensity or the amplitude, whatever you call it. Okay, now you can see that normal map covering the circle, and this is way more cooler than it was before. Let me show you the before. Look at the before, it is plain. Like you can see the colors blending, but you can see the grainy effect. Now if you just uncomment this, now you can see the grainy effect kicking on. Wow, that is the shit, that is the beautiful part about this. And if you change this normal to like 1 and check, now we have this, what do you say, like I mean a square, a tilted square, we can see that. And if you check this normal one, look at this pattern and look at this pattern. Now that is what we want, that is cool. And now if we change this to the last one, I like the last one and the first one. Now that is cool. You can see some kind of thing below this. In between this circle and this image, there is this one layer of displacement map, and that is also blending with the image. Now that is the cool part, guys. That is what we are gonna make in this channel. All the cool shit we can make with shaders. That is the best thing about shaders, that it is so magical that you can do crazy stuff with it in the website. And yeah, it is unlimited. The creativity is unlimited that you can have with these shaders. And one last thing I'm leaving up to you guys is that go search up another noise algorithms, and I'm gonna show you a GitHub repo where you can get all the algorithm. Search GLSL noise algorithms. In the first one, you get this generic noise. Like this GitHub is full of noises, and what I want you guys to do is get one of the noise, paste it here, replace it with the FBM noise. This inside parameters are gonna be the same. You're just gonna pass. Okay, I'm gonna tell you guys one more thing. If you add time, look at that crazy city. It's gonna keep moving forever even if you don't move your mouse. Now that is cool. That is way cooler. And if you add some kind of experiment variables inside this, you'll get a different effect. And creating shader effects is like experimentation. And I made this effect with experimentation. Like I was working on another project, then I don't know, I was just playing with the values and I got this venom effect. Pretty cool, right? Now, as I was saying it before, just replace it with another noise algorithm, and you'll get another beautiful effect, and which will be unique. And there's also this num octaves. If you just increase this to 10 or 20, you're gonna get a bit slightly different result. But yeah, it depends upon you. You can customize it as you want, brother. Now, I think that's it. That's it about the video. I hope you enjoyed it, and just tell me if I'm teaching it well, if I'm explaining it well, or if there is a better way that I can explain it to you guys, or a bit more practical way, or a bit more detailed explanation. I'll surely make a explain detailed video about shaders for beginners. And yeah, thank you so much for watching. Bye bye.